for the session of inverse Z transform. Actually, this is coming under VTU syllabus, and fourth semester ECE students are studying under module 5. Module 5. This is my lecture 8 sessions, actually 8 lecturing sessions. In all my previous sessions, 7 sessions. Now, this not only ECE students, anybody who is interested in Z transform and inverse Z transforms can follow this, all these sessions, right? Now, in my previous sessions, all these days, all these lecturing hours, we discussed about Z transforms, its applications, its comparisons with other transforms, and how to get Z transforms, and how to plot region of convergence, poles and zeros, and studied, plotted in Z domain, and properties we dealt, and we have used all properties, 7 to 8 properties to analyze signals, to find out Z transform, and to plot all these things, and to study X of n efficiently we did. And afterwards we went for inverse Z transforms. That's what this, in that we are getting back original signals X of n, our original signal X of n, we want to get back from the transformed sequence X of z. From this to, in all this class we said from X of n to X of z we analyzed. Now from last class to now, we are getting our original signal sequence back from the transformed Z transform sequence after analysis. Now, in the last class we told you, there are two methods of getting X of n original from X of z. One is partial fraction expansion method, the other is power series expansions method. In the partial fractions expansions method, there are two methods, two conditions, two cases. One is numerator X of z, you will get polynomials of numerator and denominator, right? If numerator, if n is less than, if n greater than m, we study. If m is less than, if m is less than n, we study. Now today we will see, if m is equal to n, numerator z power is same as denominator therefore r m greater than n, we will study. For example, I will give you like this. We will check z power of m, that is minus 2 is there, here also minus 2 is there. That means m is 2, n is 2. If m is 2 and n is 2, then second method of partial fractions, which is done by, that's what today we are discussing, partial fraction expansions by long divisions method. Long divisions method, n greater than n, m, then long divisions method. Today let me see, m is equal to n, long divisions method. Right? Now, for example, let me discuss our getting back original signals to this Z transform sequence. Find IZT of following the equations, partial fractions expansions method. He is not telling long divisions method or straight method. Now we have to see these complex equations, say complex X of Z transforms, and we have to decide which form. This is long divisions by seeing this, by analyzing this. He is not going to tell you. Now see, here 1 plus 2 Z inverse plus Z power minus 2, 1 minus 3 by 2 Z inverse plus 1 by 2 Z inverse of minus 2 with ROC mod Z greater than 1 is given. Now by looking itself, ROC mod Z greater than 1 means it is right-sided sequence. That means region of convergence exists after the radius 1, after the circle of radius 1. That means you will get in the end sequences right-sided. That is, as first look you will know this. Now here, see the power of m and n. See for example, m is 2, n is 2. Here m is 2 because z power minus 2 is maximum. N is 2. Therefore, long divisions method I have to do. Right? Second method. Now first write, given x of z as it is, 1 minus 2 z inverse plus z inverse minus 2, and denominator as same. Now immediately factorize denominator. This we have done last class also. See this, factorize this denominator. For example, 1 minus 3 by 2 is there, plus 1 by 2 is there. Now see, if I factorize, I get 1 minus 1 by 2 z inverse, 1 minus 1 z inverse. 100 times you have done in the maths, right? How do you get 1 into 1? 1. See this, 1. Then, middle term, minus 1 by 2, minus 1. minus 3 by 2 z inverse. That's what this middle term. Minus 3 by 2 z inverse. Then multiply last two. Minus into minus plus. Then 1 by 2 into 1 is 1. 1 by 2 z inverse. Z minus 1 is z minus 2. That's what you will get. See, plus 1 by 2 z to the power minus 2. When you multiply those two last two, you will get this. When you add, you will get middle. And first one is when you multiply, you get this. This is how you get factorizations. Next, bring this x of z into normal form. This x of z into normal form by long divisions method. What is that long divisions method? See this. This is numerator and this is denominator. For example, see, this is numerator, this is denominator. Now denominator you have to write like divisor, and the 1 minus this is numerator is dividend. That like a divisions I will write here. From the right side I will write. For example, the denominator I will write first. 1 by 2 z power minus 2 minus 3 by 2 z power minus 1 plus 1. See this? Denominator, what is there? This. 1 by 2 z inverse minus 2. This side I am writing. Plus minus 3 by 2 z inverse plus 1. Minus 3 by 2 z inverse plus 1 in the. See here. This is division. Next, dividend you write here. For example, what is that dividend? This is numerator is dividend. What is that? This is minus z power minus 2 minus 2 z inverse plus 1 is my dividend. See this? Z power minus 2 plus 2 z inverse plus 1. Now start dividing. Start doing like a divisions. For example, see the first term. Z power minus 2 is there. That should go actually when you subtract there also. Such a way you multiply with some term. For example, this is my divisions. I will multiply with 2. See this? 2 into 1 by 2 is 1. Z power minus 2 is z power minus 2. When you multiply this first term and first term, you will get z power minus 2. Now this gets cancelled. Now see, z to the power minus 2 minus of z power minus 2 is 0. Such a way you should multiply here. Then afterwards 2 into minus is minus. 2 into 3 by 2 is minus 3. Z inverse is z inverse. Then last term 2 into 1 is 2. Now start subtracting. This minus this is 0. 2 minus of minus 3 is plus 5. Z inverse. 1 minus of plus 2 is minus 1. Now this is your remainder. This is quotient. Now stop this. Write x of z. X of z is equal to 2 plus this quotient plus remainder. Now, first term gets cancelled. See this? Z power minus 2, z power minus 2. Minus of this is 0. Now plus 2 z inverse minus of minus 3 z inverse is nothing but plus. This is minus into minus plus. Then plus 5 z inverse. This is 1 minus of plus 2 is nothing but minus. 1 minus of, this is like this. 1 minus of plus 2 is nothing but it is equal to 1 minus 2 which is equal to minus 1. That's what I am writing here. Right? Now stop this. Now what you can do is x of z is equal to write quotient here 2 plus write the remainder this here 5z inverse minus 1 as numerator and write divisors here as denominator. 1 by 2 z inverse minus 2 minus 3 by 2 z inverse plus 1 plus 1. Now see, this is called this as x of x1 z like your previous. What is this? This is of your normal form. 2 plus, why this is normal form? See this maximum numerator power n is 1. No, n is 1. Now see, m is 2. M is 2. Therefore, n is less than m. Therefore, our normal form. Now, go for x1. This x1z is there, no? Go for these solutions. Solve this like your previous sessions. You will get apply partial fractions expansions to the second term. That is x1z is equal to 5z inverse minus 1 by 1 minus 1 by 2 z inverse 1 minus z inverse. Then you know how to solve this. x1z is equal to k1 by neglect numerator k1 by 1 minus 1 by 2 z inverse plus k2 by 1 minus z inverse. Therefore, solve for k1 and k2 like as usual. First k1, neglect k2, know this. Neglect k2, write k1. k1 is equal to like this 1 minus 1 by 2 z inverse into x1z at z is equal to 1 by 2. That's what I am writing. See this, k1 is equal to 1 minus 1 by 2 z inverse x1z at z is equal to this 1 by 2. 1 minus half is there. Observe this. K1 is equal to 1 minus 1 by 2 z inverse. What is x1z? Substitute x1z from that expression. 5z inverse minus 1. 1 minus 1 by 2 z inverse. 1 minus 1 z inverse. Right? Now, cancel this 1 minus 1 by 2 z inverse and z inverse. Then you will get 5z inverse minus 1 by 1 minus z inverse at z is equal to 1 by 2. Now, substitute z wherever is there 1 by 2. Now, see, maths 5 into 1 by 2 inverse minus 1 by 1 minus 1 by 2 inverse is equal to 5 into 2 goes up. 5 into 2, 10. 10 minus 1 is 9. Then denominator 1 minus 1 by 2, 2 goes up. That is 2. 1 minus 2 is minus 1. Therefore, K1 is equal to minus 9. K1 you got. Similarly, get K2, neglect K1, get K2. You will get K2 is equal to 1 minus z inverse x1z at z is equal to 1. Now see, right? 1 minus z inverse, what is x1z? X1z is this long divisions, whatever you are getting, know that. For example, whatever you are getting, no, this is x1z. 5z inverse. Now do that. 5z inverse, right? 5z inverse minus 1. 1 minus 1 by 2 z inverse. 1 minus z inverse at z is equal to 1. Now, this and this gets cancelled. 5z inverse minus 1. 1 minus 1 by 2 z inverse at z is equal to 1. Substitute 1 at z. 5 into 1 inverse minus 1. That is nothing but 4. 1 minus 1 by 2. 1 inverse. That is nothing but 1 by 2. Therefore, 4 into 2 is equal to 8. K2 you will get 8. Now, write final formula x of z is equal to 2 into 2 plus is there now. Into 1 you write. Why? Because is I want this is actually the impulse functions we get when you take inverse Z transform. That's why I am writing instead of 2, 2 into 1 plus what is K1 minus 9 by 1 minus 1 by 2 Z inverse already there. Substitute K1 and K2, that's all. Plus 8 by 1 minus Z inverse. 1 minus Z inverse. Now see this, from the given problem we know that mod Z is greater than 1 is given. Therefore, what is that? Meaning ROC exists outside the circle of radius 1. Outside the circle of radius 1 like this ROC exists outside this radius. That means what? Both the terms are outside, ROC exists outside means both terms are right side sequence. That means both these terms you will get U of n. That's the meaning. Therefore, both the terms are right sided only. Therefore, IZP of this x of z from the table, standard table is there. Using linear property, because a1, a2 is here, 9 and 8. We can write x of n is equal to 2 into, what is inverse Z transform of 1? It is delta n. It is there in the table. Minus 9 into, what is inverse Z transform of 1 by 1 minus alpha Z inverse, like alpha is 1 by 2. Is 1 by 2 inverse, 1 by 2 to the power n, this to the power n, into U of n. U of n is right side sequence. There is a standard formula for this. Right? That is 1 by 2 to the power n into U of n. Plus, last one is 8. 8 into 1 minus 1 is there here. 1. That is nothing but 1 to the power n into U of n. Therefore, this is there in the table. This is there in the table. What is that? From the table, alpha to the power n into U of n, Z transform of this is nothing but 1 by 1 minus alpha Z inverse. Mod Z greater than 1. We are writing reverse. Inverse Z transform of this 1 by 1 minus 1 by 2 is here, alpha in place. That inverse is nothing but 1 by 2 to the power n into U of n, right sided sequence. That's what I substituted here. That's what I substituted here. See this? Here. 1 by 2 to the power n into U of n. Right? For this. And same for this also. 1 to the power n into U of n. And second one is Z transform of delta n is 1. Inverse Z transform of 1 is delta n. That's what I am writing here. See this? 2 into delta n. Right? It seems, I hope it seems I am clear. If I want to repeat in 2 steps, see, first he will give you one example like this, one complex Z transformed sequence, where you check first factorized denominator, you will get this 1 minus, see for example, he will give you the expressions like this, right, with ROC. First factorize this denominator, you will get like this, right? And then check first, what is that? Check m and n power here. Here m is 2, n is 2. Therefore, it is second method, long divisions method only. Long divisions method, right? Bring x of z into normal form. Then write this, factorize. Then do the long divisions method. How do you do? First write the denominator as divisor, numerator as dividend. Then start doing multiplications with some term to such a way that we should get cancelled first term. Z power minus 2 I want. I should select such a way this value. 2 into if you multiply, you will get 2 into 1 by 2 gets cancelled, Z power minus 2 you will get. Similarly, 2 into minus 3 by 2 you will get minus 3 Z inverse plus 2 into 1 is 2. Then start subtracting. You will get this gets cancelled. This becomes y z inverse minus 1. Now, stop doing that. Then write x of z as remainder first 2 plus, quotient 2 plus this remainder as numerator and divisor as denominator. Now, call this x1z. This is of normal form. Why? Because is m is less than n. Minus 1 power minus 2 power. N is, right, m is 1, n is 2. Therefore, normal form. Take that x1z and write in terms of k1, k2 form. k1 by this, k2 by this. Solve k1, k2, you will get k1 as minus 9. Solve k2, k2 as 8. Then substitute here, finally, you will get x of z is equal to 2 into 1 plus k1 is minus 9 by first factor plus 8 by second factor. From the given equations, mod z is greater than 1. Therefore, what do you know? Almost exists outside a circle. Therefore, both the terms, inverse Z transform when you take, you should get RSS only, right sided sequence only, U of n only. Therefore, apply right from the table and linear property after applying, you will get inverse Z transform of x of z as original sequence x of n and inverse Z of 2 into 1 as 2 into delta n impulse function. Inverse Z of this sequence is 9 into minus 9 into 1 by 2 to the power n into U of n, right sided sequence, and plus 8 into U of n, right sided sequence. And that is how I am getting, I have done here, and it seems, I hope I am clear. This is how we will get original sequence from the transformed sequence x of z, complex sequence. Now, like this, we can use Z transform and inverse Z transform better compared to any other transformations techniques to analyze today's signal processing x of n efficiently. We can design filters and we can do any type of real-time projects so that which will be useful and which will make our today's processings of any multi-processings, right, more than 2 signals or image processings or today's signals you can detect easily, you can transmit easily, receive easily, and you can increase the speed of the processor. I hope I am clear. Next sessions I am going to explain the if m is greater than n. We have done now m less than n and we have done m is equal to n also 2 2. Then last one is if m is greater than n, then how to solve such complex x of z into x of n. I hope I am clear and thank you. Thank you very much. Right. Wait for next sessions. Thank you.